So dear students, let me discuss about the next topics of differential equation, that is method of separable variable. Okay, and with the help of an example I will discuss about orthogonal trajectories also. Okay, so let me start this method with a very simple example, and this is you already studied in your 10+2 level also, but as this is in your syllabus, so I have to revision again. So what kinds of equations are there when you need to solve the differential equation by using separable variable? Suppose you have an equation like something like this, that dy by dx is equal to f of x. Okay, sometimes this dy by dx is also represented by y dash. We will represent sometimes this dy by dx as y dash. Okay, so dy by dx is equal to f of x. If these kinds of equations are there, then you can easily separable y and x. Okay, you can easily separate. So dy will be f of x dx. Now if you want to solve, you have to integrate both sides. So if you integrate, then you will get y. So this will be a solution of this kinds of differential equation, that is dy by dx is equal to f of x. So this will be the solution, that is y is equal to f of x dx. Okay, and let me solve some examples, that the method you have to clear about this method by using some examples. And let me solve the more popular examples that you have studied in your nuclear physics also, that is the radioactive decay law. So when we solve the radioactive decay equation, then we use this separable variable method. Okay, so let me solve this problem first. So if you take this as example 1, then you know that your rate of decay, that is dn upon dt, is equal to minus lambda n. So this is your radioactive decay equation, and at t is equal to 0, I can assume that at t is equal to 0, this n is nothing but n0. Okay, so if you want to solve this equation, you have to separate n and t, because here variables are n and t. So you have to separate n. So you can write here like dn upon n is equal to minus lambda into dt. Okay, now if you integrate both sides, and lambda is constant, so you have to integrate in this way, and dn by n is equal to ln n. So it will be equal to minus lambda t plus, let me take a constant, and that is c. Okay, so now if you use the boundary condition at t is equal to 0, n is equal to n0, so what you will get? So just at t is equal to 0, so you will get from here that ln n0 is equal to t is equal to 0, so this will be 0 is equal to c. Okay, so c will be ln n0. So if this is your equation 1, then if you substitute this value of c here, then you will get ln n is equal to minus lambda t plus ln n0. So we have ln n upon n0 is equal to minus lambda t. Okay, so now if you substitute, then you will get n upon n0, you will get n upon n0 is equal to e to the power minus lambda t, or you can write n is equal to n0 e to the power minus lambda t. Okay, so this is your solution of this kinds of differential equation by using the separable variable method. Okay, now let me solve another example, and with the help of that example we will understand orthogonal trajectories also. Okay, so let me solve another example. So this is our equation 1. Now let me solve another example, that is example 2, that is x y dash is equal to y plus 1 is equal to y plus 1, and y dash means dy by dx. So you can write it in this way also, that x into dy by dx is equal to y plus 1. Now if you separate x and y, so this will be dy upon y plus 1 is equal to dx upon dx. Okay, dx upon x. Now if you integrate both sides, what you will get? This integration dy upon y plus 1, this will be ln of y plus 1. Okay, so this will be your ln y plus 1 is equal to ln x plus a constant, let me take as ln a. Okay, so what will be your solution? So it will be ln y plus 1. Okay, ln y plus 1 is equal to ln a plus ln b is equal to ln ab. So it will be something like this, that y plus 1 is equal to ax. So this is your solution. Y plus 1 is equal to ax, and here a is constant, so if you substitute a, for different value of a, you will get different equation, and that will give you a family of curve. Okay, so this equation will give you a family of curve for different value of a. And here this is equation of straight line, you can see. So if you want to draw the straight lines, okay, so what will be the straight lines? So if you want to plot this equation, that y plus 1 is equal to x, then you have this something like this, y is equal to mx plus c type. So you can write here that is equal to ax. Okay, so it will be y is equal to ax minus 1. Okay, so here m is a, that means the slope of this curve is a. Okay, so what will be the plot of this straight line? So if you have something like this, so if you have this is your y axis suppose, and this is your x axis. Okay, now here the intercept is -1, so let me take this point as -1. Okay, so you can take this point as 0, -1, 0, -1. Now what will be the straight line? Let me take for a particular value of a. So for different value of a, you will get different straight line. So let me take up for a particular value of a, you have these kinds of straight line. This is one of the value, this is for one of the value of a. Now if you change the value of a, suppose if you take the value a as negative, then you will get along this direction. Okay, similarly for different value of a, you will get different straight line, something like this. You will get different straight line. Okay, and if you imagine, if you want to compare this diagram with the physical situation in electrostatics, then if you put a point charge over here, then you can take these straight lines as electric field lines, these straight lines as electric field lines. Okay, now I want to discuss about the orthogonal trajectories, and actually you know what is the orthogonal trajectory for these kinds of lines, because you know in electrostatics about equipotential surface. So if these are the electric field lines, then the equipotential surface should be something like this, because you know the electric field lines always perpendicular to the equipotential surface. And in 2 dimension, this is actually the orthogonal trajectories, because if you draw a tangent here, you can see this tangent is perpendicular to this line. So for this family of curve, the orthogonal trajectory is here a family of circle. So you can draw more concentric circles, which in electrostatics can be taken as the equipotential surface. But here in mathematics, the solution of these differential equations here gives the electric field lines if you put a charge over here. And the equipotential surface that I have written over here is actually the orthogonal trajectories, because what is the orthogonal trajectories? Actually the curve which is perpendicular to this line, and here the curve means the tangent of this curve at each and every point, the tangent of this curve will be perpendicular to this line. And we can mathematically also determine that the orthogonal trajectory is nothing but an equation of circle. So if I want to find out mathematically that what is the orthogonal trajectories for this equation, then we can find that the orthogonal trajectory is obviously a family of circle, concentric circles. Now how you can prove this? This is the physical situation you know from your concept of electrostatics, but how you can prove that the orthogonal trajectories are the concentric circle from this equation? So what you have to do first? Let me first find out the slope of this line, because you can see here the slope of this line and the slope of this line are perpendicular to each other. These are two perpendicular lines, and you know the reciprocal, the multiplication of two slope, okay, of two perpendicular line is always -1. So if you have the slope of this line is m and slope of this line is m dash, then you always have m dash is equal to minus 1. M dash is equal to minus 1. So how you can find out m first? So if you can see here m is a because this is straight line, but in general how you can find out the a, you have to differentiate this function. So it will be dy by dx. If you find out dy by dx, then it will be just a. You can see a, and this is nothing but m. This is nothing but m. Dy by dx is m. Okay, so now if you dy by dx, I can write it as y dash also. Y dash also. Now if you want to write down this equation in terms of y dash, so how you can write it? So this will be y is equal to nothing but a y dash x minus 1. So what will be y dash? So y dash will be y plus 1 divided by x. So this is your slope of this line. Slope of this line. Now if you want to find out the slope of this line, okay, that is perpendicular to this line, so what will be this? This will be just y dash is equal to minus x divided by y plus 1, because the multiplication of these two should be minus 1. Multiplication of these two slopes should be minus 1. So y dash is equal to minus x by y plus 1. Now if you solve this equation, you should get the family of circle. Okay, so how you can do it? So if you put here y dash as dy by dx, let me put this y dash as dy by dx, then dy by dx is equal to minus x divided by y plus 1. Now again if you cross multiply, then you will get that y plus 1 into dy is equal to minus x dx. Okay, now if you integrate both sides, then what you will get? So this will be your y square upon 2 plus y is equal to minus x plus a constant like c. Okay, a constant c. So you can see what this equation is actually. So it will be just y square plus 2y, and this is minus x square by 2. Okay, so if you multiply 2, then it will be y square plus 2y is equal to minus x square plus 2c. So we will get here that y square plus 2y plus 1, let me take 1 here, plus x square is equal to 2c plus 1. So what this? This will be just y plus 1 whole square plus x minus 0 whole square is equal to 2c plus 1. So you can see this is the equation of circle whose center is minus 1, 0, minus 1 as expected here. Okay, so first what we have done, we can predict the orthogonal trajectories comparing this situation with the electrostatic situation. If you put a charge over here, then the electric field lines will be this, and we know that the equipotential surface is always perpendicular to the electric field lines. So the trajectories should be the orthogonal trajectories. That means that tangent at each and every point of this line is perpendicular. So the orthogonal trajectory should be circle. And then I have proved here mathematically also that if you know the equation of straight line, the equation of family of lines, the straight lines, then you can easily find out the slope of this line. And conversely, if you find out the slope of this line which is perpendicular to this line, and then from there I can solve for this m dash, and I end up with this equation which is a equation of circle. Okay, so in this way we can prove mathematically, and by using the comparison of electrostatic situation you can predict the orthogonal trajectories also. Okay, so orthogonal trajectory means a trajectory, that is the trajectory whose slope at each and every point is perpendicular to this line, to this family of line. Okay, thank you.